Okay, so I've recreated the pipe cleaner tree from the video at the beginning. I have different colors, but you can see they all start at the beginning. Here's their root, right? They're all round together. And then you've got trout that breaks off first. And then you've got the salamander that breaks off. And then we've got the branch that leads to humans and cows. And then we have our gecko breaking off, and then the branch that leads to our crocodile and our pigeon. Okay, so looking at the tree, it's 3D, right? It's not actually a flat image. And really what's most important, as was said in the other video, that these nodes right here, this is a branching point. It's a speciation event. It's a time when two populations got separated, and then they go on to become these other species. So in looking at question number 1, it says, is a gecko more closely related to a salamander or a cow? So to answer that question, we find gecko right here, and we follow it down, and we grab onto the node. And then it asks, is it more closely related to a salamander or a cow? Well, we got to go down one more node to get to a salamander or a cow. And if you go right here, you can see that this node will branch off into these species. And so you can see the cow, it comes at a node higher up than the salamander that shares. Okay, so cow would be the right answer. And then for why, it's because they share a more recent common ancestor than back here, this common ancestor that would be shared with the salamander. Same thing here if we look at question 3, is a crocodile more closely related to a human or a cow? So we've got to take our crocodile, which is right here on the brown, or take our crocodile and our human and our cow, and we got to find a common ancestor. So if you travel down, it's this one right here. So you can see that the crocodile branch is equally related to humans and cows because there's the node. And if you follow it out, it branches off to both. Okay, so they are equally related, and that's because they share an equal common ancestor back here. All right, so then question 5, if scientists discovered a new species that has a vertebral column, 4 limbs, lungs, amniotic egg, where would you place it on your tree? So you have to trace, and now I don't have the characters mapped on this tree, but wherever all of those characters exist, which I believe is on this branch right here, then you would branch it out from this same node. So it would branch out from here. And then question 6 asks, adding this new species, does it change the existing tree? Well, no, you're just going to have another branch coming out here, but everything else should stay the same on the tree. So adding species to a tree does not change the relationships on the tree. Same thing with adding characteristics or taking characteristics away. All right, so the most important things to pay attention to are these common nodes or common ancestors on the tree.